Number 10, you should recognize this word, phenolphthalein. You've used it several times in the lab as an indicator. It can turn pink. They say red here, but really it's pink. This particular question, I didn't write it. This came from a standardized test, an SAT subject test in chemistry. I hope this model looks familiar to you. The colorless phenolphthalein is that which has an H plus ion attached to it. The pink phenolphthalein has lost its hat, has lost the H plus. So the pink form has no H plus. So it is a deprotonation that turns the phenolphthalein pink. All right, this question is actually well done by elimination. Is phenolphthalein a strong acid? If it were a strong acid, then there would be a one-way reaction. It would always be dissociated. It would always be pink. So it can't be a strong acid. How about the irreversible? You should know that phenolphthalein easily switches back and forth between the two states. Therefore, irreversible. No, it's reversible. Absolutely reversible. C is out. And this last one here, catalyst for decomposition, would mean somehow this gets destroyed. The molecule is destroyed. And that doesn't happen. You know that. The molecule is just changed by one H plus. That's the only difference. Completely reversible reaction. So the only choice left is B. And if you did your buffer lab well, and you made a graph of pH versus base added, or in this case we'll say base added, but it's the same as if you added strong acid, then the buffer kind of chugs along, and then suddenly, boom, it breaks and the pH goes way up. And so this is the end point of the titration, is when the pH shoots up. And that's what the words in B are saying. A large pH change near the end point, that's where the pH goes zoom.